Jupiter. A giant, a king, a ruler of its domain. This massive gas giant, the largest in our solar system, holds a special place in our cosmic neighborhood. It's a swirling vortex of color, a testament to the raw power and beauty of the universe. But Jupiter's grandeur goes beyond its own impressive presence. It's a celestial shepherd, watching over a vast and diverse family of moons. These moons are not mere afterthoughts, faint echoes of Jupiter's dominance. They are worlds in their own right, each with its own story to tell, its own secrets to reveal. Some are gigantic, dwarfing even the planet Mercury in size. Others are tiny, barely visible specks of light against the backdrop of Jupiter's brilliance. Some are icy, others rocky, and some might even harbor the potential for life. This is the allure of Jupiter's moons, a tapestry of celestial diversity waiting to be explored. Each moon offers a unique glimpse into the formation and evolution of our solar system. They are natural laboratories, frozen in time, that can help us understand the processes that shaped our own planet. Among these enigmatic moons, some are well known, like the volcanic inferno of Io or the icy plains of Europa. Others remain shrouded in mystery, their secrets hidden beneath layers of cosmic dust and distance. One such enigmatic world is Cyllene, a small faint moon orbiting in the vastness of Jupiter's gravitational embrace. The year was 2003. Astronomers, armed with powerful telescopes, were conducting a survey of the outer solar system. Their gaze swept across the vast expanse, searching for faint, distant objects that might hold clues to the universe's origins. It was during one such observation, amidst a sea of stars, that a faint, previously unnoticed point of light emerged. This tiny blip, barely discernible against the cosmic tapestry, would soon send ripples through the scientific community. It was a moon, a small celestial body orbiting the mighty Jupiter. The discovery, made by a team of astronomers led by Shepard, instantly added another member to Jupiter's already impressive family. Like many scientific breakthroughs, the finding of Cyllene was a testament to both meticulous planning and a touch of serendipity. It underscored the ever-evolving nature of our understanding of the cosmos, where even the most advanced instruments can reveal hidden wonders lurking in the darkness. This newfound moon, initially designated as S2003J13, was a testament to the power of human curiosity and our relentless pursuit of knowledge. It was a reminder that even in the 21st century, our solar system still held surprises, waiting to be unveiled. The discovery of S2003J13 sparked a flurry of activity among astronomers worldwide. Telescopes were trained on this faint object, eager to decipher its secrets. Observations revealed a small, irregularly shaped moon, its surface likely scarred by countless impacts from asteroids and comets over billions of years. The moon, later named Cyllene after a nymph from Greek mythology, was determined to be just over 2 kilometers in diameter, a mere speck compared to the colossal size of Jupiter. Its surface, likely composed of a mixture of rock and ice, reflected only a tiny fraction of the sunlight that reached it, making it a challenging target for even the most powerful telescopes. Despite its diminutive size and faintness, Cyllene held a certain allure. It was a relic from the early solar system, a time capsule preserving clues about the chaotic environment in which the planets formed. Its irregular shape hinted at a violent past, perhaps a testament to collisions and gravitational interactions that shaped the Jovian system. As astronomers delved deeper into the data, they began to piece together a clearer picture of Cyllene's place within Jupiter's intricate lunar system. It belonged to a group known as the Pasiphae group, a collection of outer moons that shared similar orbital characteristics, suggesting a common origin. Cyllene, in the vastness of space, is but a tiny world. Its diameter, a mere 2 kilometers, makes it a dwarf even among Jupiter's many moons. Imagine a rock, barely large enough to hold a small town, tumbling through the void. That is Cyllene. Its small size has a profound effect on its character. Unlike larger moons that can hold onto atmospheres or generate internal heat, Cyllene is geologically inert. It's a cold, quiet world, its surface untouched by the dynamism we see on larger celestial bodies. Yet this diminutive size does not make Cyllene insignificant. On the contrary, its very existence offers valuable clues. Its size and composition place it firmly within a category of objects known as irregular satellites. These small, captured bodies are believed to be remnants from the early solar system, providing a window into a time when planets were still forming. Studying Cyllene, therefore, is akin to looking back in time. By understanding its properties, we gain insights into the conditions and processes that shaped our cosmic neighborhood billions of years ago. Cyllene, like many of Jupiter's outer moons, is shrouded in mystery. Its distance from Earth and its faintness make it a challenging target for even the most powerful telescopes. Yet, astronomers have been able to glean some information about its composition and appearance. Based on its spectral characteristics, which refer to the way it reflects light, scientists believe that Cyllene is primarily composed of carbonaceous materials. These are dark, carbon-rich compounds that are thought to be common building blocks of the early solar system. This composition suggests that Cyllene likely formed in the outer regions of the early solar system, where these materials were more abundant. Over time, gravitational interactions may have nudged it closer to Jupiter, where it was eventually captured by the gas giant's powerful gravity. Its surface, likely a dark mottled grey, is pockmarked by countless craters, the result of billions of years of impacts from asteroids, comets, and other space debris. These craters, ranging in size from small pits to larger depressions, tell a tale of a violent and chaotic past, a testament to the relentless bombardment that characterized the early solar system. Cyllene, in its celestial journey, waltzes around Jupiter from afar. Imagine a vast empty stage, with Jupiter as the brilliant central star. Cyllene, a tiny dancer in the cosmic ballet, traces a wide, looping path around this star. It's a distant dance, this orbital path. Cyllene circles Jupiter at an average distance of about 24 million kilometers. To put that in perspective, that's roughly 60 times the distance between the Earth and our own moon. This distance means that Cyllene experiences Jupiter's influence in a muted way. The giant planet's gravity, while still holding Cyllene in its sway, is a whisper compared to the powerful pull it exerts on its closer moons. And so, Cyllene travels its solitary path, a distant admirer of Jupiter's majesty, forever bound to its gravitational master. Cyllene's dance around Jupiter, though distant, follows a precise rhythm dictated by the laws of gravity. It takes approximately 2 Earth years for Cyllene to complete one full orbit around the gas giant. This orbit is not a perfect circle, but rather an elongated ellipse. This means that Cyllene's distance from Jupiter varies throughout its journey. At its closest approach, or perigove, it comes relatively near to the giant planet. At its furthest point, or apogee, it swings out into the depths of space, far from Jupiter's intense radiation belts. This elliptical path has implications for Cyllene's environment. As it draws closer to Jupiter, the gravitational forces tugging on it increase, causing slight tidal stresses within the Moon's interior. These stresses, while likely minimal due to Cyllene's small size, could potentially generate a tiny amount of internal heat. As Cyllene retreats back to the outer reaches of its orbit, these tidal forces lessen, and the Moon returns to its cold, quiet state. This constant push and pull of gravity, though subtle, plays a role in shaping Cyllene's long-term evolution. Cyllene is not alone in its distant dance around Jupiter. It belongs to a class of moons known as irregular satellites, a motley crew of celestial objects that stand apart from the more familiar larger moons. These irregular satellites, as their name suggests, don't conform to the neat, orderly orbits of their larger siblings. They tend to have wide, elliptical orbits, often tilted at extreme angles relative to Jupiter's equatorial plane. Astronomers believe that these irregular satellites are not native to the Jovian system. Instead, they were likely captured by Jupiter's gravity long after the planet formed. These captured objects, hailing from the outer reaches of the early solar system, bear witness to a time of planetary migration and cosmic upheaval. Cyllene, with its inclined and eccentric orbit, fits the profile of a captured object. It's a cosmic immigrant, forever bound to Jupiter after a chance encounter in the vastness of space. Imagine a grand family portrait of Jupiter and its many moons. In the center sits Jupiter, the patriarch, a giant among giants. Around it, in a series of concentric rings, orbit its largest moons, the Galilean satellites, each a world unto itself. Further out, beyond the realm of the Galilean giants, lies a more sparsely populated region. Here, in the outskirts of the Jovian system, we find the irregular satellites, including Cyllene. They are the distant cousins, the adopted members of this celestial family. Despite their distance and their unusual origins, these irregular satellites are an integral part of the Jupiter system. Their presence provides valuable clues about the planet's history, its gravitational influence, and the chaotic early days of the solar system. Cyllene, though just a tiny dot in this grand portrait, plays a role in our understanding of this complex and fascinating planetary system. Its study, along with that of its fellow irregular satellites, helps us paint a more complete picture of Jupiter and its place in the cosmic order. Cyllene, a tiny world in the vast expanse of our solar system, presents a formidable challenge to scientific observation. Its small size and extreme distance from Earth render it a faint, elusive target, even for the most powerful telescopes. Despite these obstacles, astronomers have not shied away from studying this distant moon. They employ a range of sophisticated techniques, pushing the limits of our technological prowess to glean information about Cyllene's properties and history. One of the primary tools in their arsenal is spectroscopy, a technique that involves analyzing the light reflected from Cyllene's surface. By breaking down this light into its component colors, like a prism splitting sunlight into a rainbow, scientists can identify the chemical fingerprints of different materials present on the moon's surface. These spectral observations, while challenging due to Cyllene's faintness, provide crucial insights into its composition. They suggest a surface rich in dark, carbon-rich compounds, hinting at its formation in the cold outer regions of the early solar system. Light, that celestial messenger, carries whispers of distant worlds, and Cyllene is no exception. Astronomers, by carefully analyzing the subtle variations in light reflected from this distant moon, can decipher clues about its surface properties and even its history. One technique involves studying the way Cyllene's brightness changes as it rotates. These variations, though subtle, can reveal information about the shape, size, and distribution of craters and other surface features. Furthermore, by observing Cyllene in different wavelengths of light, from visible to infrared, astronomers can gain insights into the temperature variations across its surface. These temperature maps can help identify areas that might be warmer due to recent impacts or other geological processes, however unlikely they may be given Cyllene's small size. These observations, pieced together like fragments of a cosmic puzzle, gradually reveal a clearer picture of Cyllene, a small world shaped by time, gravity, and the relentless bombardment of the cosmos. Cyllene, though a small and seemingly insignificant celestial body, holds within its ancient surface a record of events that transpired billions of years ago, during the chaotic early days of our solar system. Its very existence as a captured object, most likely originating in the outer reaches of the solar system, speaks volumes about the dynamic processes that shaped the planetary neighborhood around Jupiter. The craters that pockmark its surface, each a silent testament to a cosmic collision, provide clues about the frequency and intensity of impacts in the early solar system. By studying the size distribution and morphology of these craters, Scientists can infer information about the population of small bodies that once roamed the outer solar system. Moreover, the composition of Cyllene, believed to be rich in carbon-based materials, provides insights into the distribution of these building blocks of life in the early solar system. Cyllene, therefore, serves as a time capsule, preserving within its ancient surface a record of events that transpired billions of years ago, offering a glimpse into a pivotal chapter in the history of our cosmic neighborhood. Cyllene, for now, remains a distant and enigmatic world, its secrets closely guarded by the vastness of space. However, the future holds the promise of closer encounters and more detailed observations. As technology advances, new generations of telescopes, both Earth-based and space-borne, will possess the sensitivity and resolution to study Cyllene in greater detail. These instruments will allow astronomers to map its surface with unprecedented precision, revealing the intricacies of its craters, grooves, and other geological features. Furthermore, future space missions, perhaps inspired by the success of missions like Juno and JUICE, might target Jupiter's irregular satellites, including Cyllene. A dedicated mission to Cyllene could involve a flyby or even an orbiter, equipped with instruments to analyze its composition, study its interaction with Jupiter's magnetosphere, and search for signs of any internal activity, however unlikely. These future encounters with Cyllene, driven by human curiosity and our insatiable thirst for knowledge, promise to unlock further secrets of this distant world, shedding light on the formation and evolution of the Jovian system and enhancing our understanding of the cosmos we inhabit. Cyllene, a diminutive moon in Jupiter's vast retinue, might seem, at first glance, unremarkable. Its small size and distant orbit place it far from the spotlight that shines on its larger, more dynamic siblings. Yet, to dismiss Cyllene as insignificant would be to overlook a valuable piece of the cosmic puzzle. Cyllene, like other irregular satellites, serves as a window to the past, offering us glimpses into the tumultuous early days of our solar system. Its very presence in orbit around Jupiter hints at a time of planetary migration, when gravitational interactions scattered and reshuffled the building blocks of planets. Its cratered surface, a testament to billions of years of impacts, provides a record of the bombardment that shaped the early solar system. Its composition, rich in carbon-based materials, offers clues about the distribution of these essential building blocks of life in the early solar nebula. By studying Cyllene, we are not simply cataloging celestial objects, we are deciphering the history of our cosmic neighborhood. This tiny moon in its silent orbit holds within its ancient surface the stories of our solar system's formation, a time when planets were born from a swirling disk of gas and dust. The exploration of our solar system is a journey without a final destination. Each new discovery, every piece of data we gather, only deepens our understanding and fuels our curiosity to learn more. Cyllene, though small and distant, is no exception. As technology advances, we can look forward to a future where we can study Cyllene in greater detail. New telescopes, both on Earth and in space, will allow us to peer deeper into its surface, unraveling the mysteries hidden beneath its cratered facade. Future missions to the Jovian system might even include a dedicated mission to Cyllene. Such a mission, equipped with advanced instruments, could provide unprecedented insights into its composition, internal structure, and interaction with Jupiter's powerful magnetosphere. The quest to understand Cyllene is not just about this one small moon. It's about unraveling the larger story of our solar system's formation and evolution. It's about satisfying our innate human curiosity to explore the unknown, to push the boundaries of our knowledge, and to comprehend our place in the vastness of the cosmos.